In transportation, a very common practice is work zone inspection. Now you have two things. One is about knowledge that is summarized by the standard, and then you have the real world work zone. And a person's gonna go through a menu, learn it, and apply it to the real world to make sure that everything works okay. This can be generalized to manufacturer quality control. This was actually very difficult for computer technologists before because it's very hard for computers to understand a menu. It's also very hard for computers to understand a physical world with spatial intelligence. But now the technologies have made breakthroughs in both areas, and you could use like these foundation models and put them into agents, even work better to send an agent to understand the menu and send other agents to understand the real world. We can use our autonomous vehicles to let them drive by these areas to do this kind of inspections. And this kind of agentic AI-based system inspection is going to be a very important step, not only to transportation, but also to the manufacturing verification quality control. And that's actually one step before robotics.
We're not trying to graduate students that can compete. We want students who know how to lead, who know how to question, who know how to collaborate, and can be in a world where AI is a part of their work. So I'll talk a little bit about how we are preparing them to come out into the world and join all of you in the workforce. I teach the computer science capstone. Students work for a semester on a cross-functional team. Someone's a designer, someone's a product manager, a couple folks are developers, and they have real-life clients. They provide projects and work and mentor the students throughout the semester. So we're thinking about how do we make sure in these contexts students get practice with critical evaluation? How do we do side-by-side critiques if you've done some vibe coding and then you compare it with what you wrote yourself? What's same? What's different? What works? What doesn't? What different choices does the AI make versus what you as the developer make? We also in assignments include reflection components to kind of think about, okay, I used AI on this assignment. It was allowed. How did it help me learn? What new light bulb moments did I have as a result of using this tool? So we're not forbidding them from using things, but we're asking them to really actively think about how is it enhancing your learning experience.
We are in the right timing that most of technology has been de-risked already. It's time to grow them into businesses. So at this moment, we are trying to down select the manufacturing process that can work for space manufacturing, identify the materials, and how we can develop the prototypes that work for space manufacturing. The idea for space manufacturing is to continuously support these missions. If we want to go to Mars, the one-way ticket, it takes 2 years to get there. Anything got broken along the way, we don't have any backup parts. The most common way that we try to resolve is try to find the best 3D printing technology that can work for space. 3D printing technology, they don't work under zero gravity. If it's metal powder, without gravity, they fly all around. So my team has been focusing on one type of specific technology. It's called electrohydrodynamic inkjet printing. I call it EHD printing for short. This is the process, we use electrical force to control the material flow and deposition very precisely. So the electrical force is a replacement of gravity force that we typically use for 3D printing system. I'm also proud to share that Dean Devesh Ranjan has recently issued us a new grant to build a small microgravity environment on campus. So in the future, we do have some facility to test zero gravity experimentation on campus, hopefully to be finished in the upcoming year.